Okay, here is some basic trig review you're going to need for this course. So if we go back to a unit circle where we have a right triangle inside where theta is our angle, keep in mind theta is always going to be in radians. We don't deal with degrees at all. We have an x distance, we have a y distance, and we have an r for our radius. So we have 6 trig functions here: sine, cosine, tangent, cosecant, secant, and cotangent, which are defined using this unit circle. So the sine of our angle is that y distance divided by the radius. If the radius is 1, which of course it is in a unit circle, this would simplify to just sine of theta equals y. Likewise, cosine is x over r. Alright, again, if r is 1, the x value would just be cosine of theta. Tangent, you need to know that is sine over cosine. And then we have our reciprocal trig functions. You have to know that cosecant is paired with sine, secant is paired with cosine, and cotangent is paired with tangent. Okay, so these are reciprocals. Alright, so you need to be aware of that. So if sine over cosine is tangent, then cosine over sine would be cotangent. Okay, so you have to know those 6 basic functions. Also need to be aware of popular angles. Now, this entire course is in radians. You're not going to see problems in degrees. At least it's extremely rare if you do. So we need to be aware of these popular angles. So 30 degrees is pi over 6. Alright, you really just need to keep in mind that pi radians is 180 degrees. From there, all these other ones are born. So 60 is pi over 3. Think of it as 180 over 3. Okay, we've seen these before. Okay, these are ones you want to commit to memory. Okay. Also, be on the lookout for multiples. So if you see something like 7 pi over 6, look at that pi over 6 that's inside of it. Alright, you know pi over 6 is 30. So we really have 7 30s, which is 210. Okay? Don't forget about the big 3. Sometimes you're not going to be allowed to use a calculator, and you're going to have to evaluate things like the sine of pi over 6, cosine of pi over 3. Those are each a half. Remember, pi over 6 is 30, pi over 3 is 60. So the sine of 30 is a half, the cosine of 60 is a half. And then we have the tangent of 45 degrees, or the tangent of pi over 4. That is 1. Okay? So we need to keep this stuff in mind as we move forward in the course. Okay, we're going to look at inverse trig functions now. So our first one, we see y equals cosine, and it's raised up to a -1. We read that as inverse cosine of x. Recall that -1 is our inverse notation. So inverse cosine of x, we have another name for that. We call it arc cosine of x. And likewise, there are 5 other ones. We have inverse sine, inverse tan, inverse secant, inverse cosecant, and inverse cotangent. So we're going to look at an example here where this is used, and I'm going to change this to a negative 0.7. So if you already copied that down, please make that a negative. So we're looking to solve this equation. We see the sine of theta equals negative 0.7, and we're looking to solve this for angles between 0 and 2 pi. Now, we're talking about radians here, and 2 pi, recall, is approximately 6.28, so you're not always going to see radians expressed in terms of pi. So keep in mind, since pi is about 3.14, 2 pi is about 6.28. So if we are looking to solve this equation, what we need to keep in mind is we're looking to get theta, our angle, alone. So in order to do that, we need to undo this sign. The way we undo that sign to get theta alone is we need inverse sine. So this is where we're going to see our inverse trig functions. So we need our inverse sine of that negative 0.7. Now you've seen this before, you've done it in the calculator. You'll always be allowed to use a calculator for problems such as this. So make sure you are in radian mode in your calculator and do inverse sine, so that's second sine of negative 0.7, and let's jot down what we get. So notice we get negative 0.7754. Typically during the middle of a problem you want to go out 4 or 5 digits after the decimal. At the very end we'll round, we'll take it out to 3 places. That's generally what AP asks for. So that's one solution. Now we have to go back to our ASTC, which tells us where the trig functions are positive in the 4 quadrants. So notice that we're dealing with a negative number. So we want to determine, since we're talking about sine, we need to be aware of which quadrants sine is negative in. Well, sine is negative down here in our 3rd and 4th quadrants. So when we entered this into the calculator, we got negative 0.7754. Understand that your reference angle is really positive 0.7754. The reference angle is always going to show up here in the 1st quadrant. Okay? We don't want that 1st quadrant answer because sine is negative here. So what we need to do is we need to look at how to get our answers in quadrants 3 and 4. Well, in quadrant 3, recall if we were in degrees, we would be doing 180 plus our reference angle. So in this case, 180, since we're always in radians, is pi. So we need to do pi plus our reference angle. So the reference angle is 0.7754. And likewise, to get our quadrant 4 answer, in degrees we would be doing 360 minus our reference angle. Well, 2 pi is 360. So 2 pi minus that 0.7754. If we go straight to our calculator for those, we're going to end up with, and it's okay now to round, we're going to go out 3 total digits after the decimal. Okay, so these would be our 2 answers. We don't want to use our original answer of negative 0.7754 because notice up here our domain is dealing with positive angles between 0 and 2 pi, or in other words between 0 and approximately 6.28. So this negative 0.7754 is really the 4th quadrant angle of 5.508. Okay?